The NC Lab 2020 webinar series is funded through a grant from the Institute for Museum and Library Services and provided to the Nevada State Library Archives and Public Records System. The topic for webinar 6 is Visual Intro to Python, Units 1 and 2. We're going to move over to Visual Intro to Python, and I'm going to go to my handy dandy documents down here as a starting point. And again, these are things you can hand out or share electronically. It used to be called the Turtle course, or Tina Turtle, and it's now called Visual Intro to Python. And it teaches programming two ways. One is through drawing, and then the second part of the course really teaches it through robotics. So these are what you call autonomous robotics. It's sensors, and the robot is responding to information on its own. And when I did some research last year on why is it called Turtle, it turned out that after the Second World War, a lot of scientists were studying animal behavior, and they were building robots that were animal-like. One of the first autonomous robots had wheels, and it had a dome lid on everything, and it had a sensor out front, and it looked kind of like a turtle. And then MIT added a pen at the back of it that it dragged behind it and would make drawings on a floor, and that looked like the tail. So Turtle stuck for drawing programs, and a lot of the algorithmic thinking in turtle drawing is the same as it was way back when. Of course, that gets coded into scripts, and the language we use for our turtle is Python. Definitely the coding requirements in Visual Intro to Python are a little steeper than Carol, although towards the end Carol starts getting more Python-esque, but here we're starting out with Python. And even more so, we don't explicitly saying that they're doing object-oriented programming, but they are using object-oriented programming. And in this case here, Tina is an object that's in the class of NC Lab turtles. And the way we use our notation is the functions are actually methods. So you'll see the object and then a period and then the function, and that the whole thing that ends up being called a method for working with those objects. So they're getting into some coding that is very much the way coding is done in Python. And there's a lot more. You can see that you're using parentheses because you're providing it with an argument, or if it's a variable, it's still a parameter that's going to be filled by an argument from somewhere else. So anyway, it's kind of fun. Instead of seeing a robot going around a maze, you're seeing a drawing, and the drawing will give you immediate feedback on your program. And then in Unit 3, you're getting into robotics, and again, we're working with conditional programming and randomly generated functions. If people are wondering where to start, people who are comfortable with typing scripts, maybe enjoy drawing, maybe they've had a little exposure to coding, they might just dive into Visual Intro to Python. But really, if they have no background in programming, Carol is still the best place to start. It focuses on principles and methods, and you're not trying to decipher a programming language and learn those principles and methods at the same time. But I do know some people enjoy going straight to Visual Intro to Python as opposed to playing Carol. So, they can always start here, and if they don't like it, they can go back. So in the first unit, you have to learn all your basic commands. Just like in Carol, we learned go, left, right, get, put. You have to learn what the drawing controls are. So you first of all have to learn how to generate the turtle, And then you're learning how to draw a line, and you can learn how to control the line width and color. You learn how to turn an angle, and then you learn these important pen up and pen down functions. So if you want the turtle to move somewhere without drawing a line, you have to lift the pen and then later on put the pen down again. And I don't know how many of you ever worked with old pen plotters, but you can definitely visualize that. If you don't want it to draw a line, that pen has to come up and then go back down again. And then one fun aspect is that all of these drawings can be extruded to 3D, and they can be exported as STL files, and they can be 3D printed. And this is where we get to make fun little pendants and things like that out of our designs. Or you can make your initials and make a pendant. This, small projects, and we cover those extensively in last year's webinars. So I'm not going to repeat that here, but you have lots of resources on how to do that. And these days, some of these kids have 3D printers at home, or they have ready access to one. The cost of 3D printing has come down quite a bit. Also in Unit 1, well, I'm going to go, that's just our preamble on how it looks for people who aren't familiar. I did mention here that this program really lends itself to fooling around and making your own drawings. So I put a mention in here of Creative Suite, and you would go to the Python Turtle app because it has specifically the right libraries and language to build drawings using the Turtle method of drawing. So in section 1, yes, you're learning some very basic skills. The window looks like this. You have your instructions up here, your code down here, and instead of the maze, you just have an XY coordinate plane, and then you can see how the turtle moves. So if you step through a program, you'll see the turtle move one step at a time in the program, or you can just run it and it'll produce the final drawing. Just a heads up, when you do step through, the very first step is always really slow. There's a lot of stuff being loaded initially, and then it goes pretty quickly through the rest of the lines. There's also, you'll see this little eye here, and that brings up it's a debugging tool. It tells you exactly what's happening to each object and variable in the program. And since we're thinking more in terms of Python, this is a very useful tool. So in section 2, you're adding some more capabilities. You can set the line width. You can hide the turtle at the end. You have this back command that'll put the turtle back so many steps. And it also, it's a whole routine here. It lifts the pen, it moves the turtle back that many units, and puts the pen down again. And then an extrude command, which will turn your drawing into 3D. It'll turn the whole drawing into 3D. And then we're also making use of coordinates. So the go to command draws a line from the turtle's current position to a particular point. And so sometimes it's very hard to draw otherwise. If you just turn an angle, you might turn some horrendous angle to get to that point. If you use go to, you get exactly there, and the computer does all the heavy lifting on figuring out how to get you there. Then in section 3, now we're already jumping into loops. Remember in Carol, in section 3, they learned the repeat loop. Well, here we're learning the for loop, which was learned in section 19 in Carol. So we're jumping into Python for loops, and we're also using a type of Python for loop that uses an index, that's the I value, and then a range number. The range number is giving the number of repetitions. There are many ways to use for loops. This is one of them. But we're using some very simple geometric patterns. So for example, when we draw a square in our for loop, we're we're repeating it 4 times, and every time Tina the turtle is going forward 30 units and turning 90 degrees. And after doing that 4 times, we have a square, we jump out of the loop, we extrude the drawing, and we display it. So it starts, again, very simple. And then in section 4, we're using the for loop to repeat patterns that are found in realistic objects. So we're making sets of stairs, we're making corrugated roofing, we're making cookie cutters, and we're also learning how to draw curves. And this is quite mathematical, so you're looking at the radius, the number of degrees you're going to turn, and then you give it a switch as to whether you're going left or right. So that, and then in section 5, just like in Carol, we start looking at nested loops. So again, these are repetitions within repetitions. And in this case, the inner loop is drawing the triangle, so it's got 3 repetitions. It has the turn angle, it has the distance, and the turn angle that we need to draw a triangle. And then we jump out of the loop and we angle the turtle 60 degrees so that it can start drawing another triangle. So this outer loop controls the inner loop. It calls it, and it also adds this turn so that you end up with this nice pattern of 6 triangles rotated around this one point. Very simple. And then as you can see, we're not going to stay simple. We're going to build some fun mosaic patterns using different polygons and different repetitions. And we're going to build something that looks like a gear. So this is getting into programming that would be used in design. And then we're creating something a little more artistic, but also quite complex to program. And you can see the inner loop is building each of these arms, and then the outer loop is repeating those arms 6 times. And then at the end of unit 1, you get a nice certificate again. So that's unit 1. It gets you through the basic drawing skills, and it also gets you started on for loops. Well, unit 2 is now going to build on that. So again, this language here starts to look very programmy. We're talking about local and global variables. We're talking about the index variables. We're talking about parametric design. We're talking about custom functions, function parameters and arguments, and so forth. So we're using the language of programming. It starts out pretty simple. In section 6, we're now really looking at this I, for I in range 5. Well, what can you do with I? This is a value. It's a counter, but we can actually use that counter in our calculations. So if I just write a simple for loop here for I in range 5, and I just print out the value of I each time it loops, you'll notice that the first value is 0. And this is true of lists. The first value is always 0. We mentioned that when we're talking about Carol. So I get a list of numbers at 0, 1, 2, 3, and 4. And then if I run this program, and you'll notice now in the body of my loop, I'm printing out this little algebraic expression. I'm taking the number 10, which is the same as going 1 unit on the grid, and then I'm multiplying the index value by 10 and adding it to that 10. So my first index value is 0. So if I go 10 times 0, that's 0. I add 0 to 10, I get the number 10. And then the next time it's 10 times 1, then it's 10 times 2. So at the end, it's 10 times 4, which is 40 plus 10 to get 50. So we're sneaking in a little bit of algebra now. And with that, we can make some pretty cool designs. So here's a case of simply every time that loop runs, we're doing a little math magic on that index to change the length of the line. And we can create all kinds of patterns with that technique. So that whole section explores how to work with that index inside the loop. And then in 7, now we're getting into some program design. So when you're designing a program, you've built this nice piece of code. It's fairly complicated. It does what you want, and then you don't want anybody else to touch it. That's getting into API design. But so let's say you have a user. You don't want them messing inside your for loop. And that user could be you, right? We talked about this before. We write comments for our future self. Otherwise, we won't remember what we did. Well, this user that's going to mess up your code could be you. You could accidentally change something and then spend hours and hours trying to figure out what went wrong. So all of these things run on parameters. You know, if I'm going forward 10, that's a value that I put inside my loop. If I turn 90 degrees, that's a value. But what I can do instead is I can declare those values outside. And then I'm not touching my program inside, but it's accepting those values to run. And I'll just show you how that works real quick. I'll go to the desktop, and we'll go to Visual Intro to Python. And let's go to section 8, unit 2, section 8. Okay, I'm going to find a demo here. Let's see if this is, okay, this is actually fairly complex. Okay, this is creating a Big Dipper, and each of the functions, am I in, no, I'm in 7, that's why I thought, wait a moment, I'm not that far along yet, I'm in 7. Okay, never mind. All right, let's take a look at 7.5. Okay, so this is getting back to polygons, and the same program will draw all of these polygons. All you have to do is give it the number of edges. So for a pentagon, that would be 5. For an octagon, that would be 8. And the edge length, because we want to see how big it's going to be. And we can program all the rest in. So here's my little program here. And this time I'm using a parameter. N is the number of edges we're going to have, and E is the length of the edge. And I can calculate the angle by simply dividing 360 degrees by the number of sides. This is a neat trick, a little mathematical trick. And now I can use it with any combination of edges and or side length and number of edges. So if I run that with what it has, okay, and I'm going to zoom that in a bit. I've got a nice octagon. If I now go and change this, let's see, let's say I want to make it a triangle with an edge length of 20, and I'm only going to have 3 sides. See, I'm changing these 2 numbers up here. I'm not messing with my program. I'm staying out of trouble. And there I have a triangle. So this is calling out your parameters ahead of the program. And it's a very important step in learning how to design programs to be used by other people. So let's just go back to our document here. So all of these lovely mosaics can be, you can design your program parametrically so that those nested loops aren't touched. You just feed it the inputs and it'll generate your output. And then now that we know how to do that, now that we know how to set those variables and give them values, we're ready to build the functions. So that code that stood alone in our program, we can define a function, and we use the DEF words just like we did in Carol to define keywords and functions there. That's Python, so we're defining it. And also one thing you have to notice with Python is that it's now using punctuation. So anytime you have a for loop or a function definition, all kinds of things, you're telling the computer that you're making that statement by putting a colon at the end, and then the indent is giving you the body the commands that it has to execute. You also have the keyword return, and if you're returning a value to another part of the program, that return stores that value to be used somewhere else. And then section 9, we're just continuing with our understanding of functions. We're adding more parameters. We're calling functions from other functions. This is really getting pretty deep in function design and different ways to use it. And then section 10 is a little fun. This actually sort of bleeds over a little bit into the 3D modeling course. And it also it prepares people a bit for the thinking in CNC design. So let me just jump to that. That's in 10. And we'll go to the demo there. And the way it works is that you build a trace in the XY plane. So, and Pablo calls it a contour here, but you're just drawing a line with the turtle. And this one's starting at the origin, and it's running parallel to the y-axis, and then it goes out. And then the program rotates it around the y-axis. This is called an axisymmetric design, and it's just rotated around the axis. You can make solid objects, you can make shells, and both of those are 3D printable. And then you can also make something called a surface, and a surface you can't print. It's something, but it's something that might be useful, say, in animation, where you don't want to have a lot of computational cost. So this whole section goes through building things with, or doing these rotational solids and building a new type of 3D object. And it explores more about function design. So I'm just going to build this here. Like I said, it's always a little bit slow to begin with, and hopefully you can see that. I'm going to just reduce this a little bit. There we go. Scoot it over like that, and I can see it better. Okay, so we have generated our turtle. Oh, it went, I ran the whole thing. Sorry, I wanted to step through it. Let's see if it'll let me step through, because I wanted to show you how it gets built. Okay, so there's our grid. There's our turtle. It's changed color to steel. And now I jumped a few steps there. It turned left 45 degrees. It went 5, and now it's turned again. So it's now parallel to the y-axis. It goes 30 units, and then it turns to the right 45 degrees. It goes 10 units. And then here's our magic command rosol that'll rotate it around the axis and make a solid. And there's our nail. And that's how it works. And again, all those things can be exported as an STL file, and you can send that to a printer. So that's basically it for units 1 and 2. As always, you get a certificate. And I'm going to pull up the chat window because I didn't do that right last time. Chat, there we go. All right, so anything you need to know about these first 2 units in Visual Intro to Python, or any other questions you might have?
Sheila, what is Plasm?
Plasm, it's a programming language for solid models, I believe. It's interesting because it has a C++ engine and a Python shell. So there's some interesting programming underneath. But it's basically what you learn when you're doing the 3D modeling course. There's a couple benefits. You're and we'll cover that more depth when we do the 3D modeling course. But you're still learning a little bit of programming. You're scripting it. You have to pay attention to your logical sequence. You're also learning geometry, and then you're also learning how computer-aided design works. So, are you going to use it commercially? No, it's really still a teaching language. It's a lot of fun. You can build some pretty cool things. But it's really, it does for CAD what Carol does for programming. It really helps you understand how things are built with the computer. And then if you go and learn AutoCAD or SolidWorks or any program that involves solid geometry, you have a pretty good background. Alrighty, well, I'll see you guys next Thursday. We'll finish up with Visual Intro to Python. Let me check my calendar because I keep forgetting when these things are scheduled, and then I misspeak. So let's see, next Thursday. Yes, we just have the one next Thursday. But it's pretty deep. There's some really cool things you can do with a turtle to simulate robotics. So it's worth spending a whole session on. So Lene, which Python are you doing? Visual Intro to Python, or are you doing the other Python course, the Python programming? Ah, okay, cool. All right. So I'm glad you have a little bit of an overview, and yeah, it's again, it's a great way to get into programming because you have this very immediate visual output. Plus, you can make some cool stuff with it. So, all right. Well, if there aren't any other questions, I'll say goodbye for this week, and we'll see you next week.
Thank you.
All right. Take care, everybody.
Thank you, Sheila. Bye, everybody.
Bye-bye.